Hello and welcome again to Geometry Section 7.1, Ratios and Proportions today. Simplifying ratios. First we need to define what a ratio looks like or what it is. A ratio is a comparison of two different numbers. It can either come in fraction form, is written as A over B, or in ratio notation with a colon off to the right there, A to B. Simplifying ratios, if we have ratios given to us in fraction form here, for instance the first one, 12 centimeters to 4 meters. The first thing we want to do with simplifying ratios is making sure that the measurements on both top and bottom of the fraction form are the same. So we want to go ahead and convert centimeters and meters into a equal measure. We'll do that by taking the larger of the two measurements, the meters, as meters is bigger than centimeters, and converting meters into centimeters. It turns out that there are 100 centimeters in 1 meter, and I take then how many meters I have, 4, multiply it by 100, and I get 400 centimeters. Once I have the top and bottom the same measure, I can go ahead and simplify the fraction. So 12 400ths can be simplified down to 3 100ths. So our ratio then is 3 to 100 centimeters. Continuing on then for the next three, we'll simplify each one of the ratios here. So 6 feet to 18 inches. Feet is bigger than inches. We know that there are 12 inches in a foot. So I will take 6 feet and multiply it by 12. I'll end up with 72 inches over 18 inches. And then 72 over 18 simplified the fraction is just 4. So my ratio is 4 to 1 in terms of inches. The next one, meters and kilometers. We have kilometers being larger than meters. There are 1,000 kilometers in 1 meter. Therefore I will take my 2 and multiply it by 1,000. I'll end up with a ratio of 1 meter over 2,000 meters, and that is simplified, 1 to 2,000. Lastly, yards and feet. Yards is the larger of the measurement, as there are 3 feet in every yard. Simplifying then, I multiply the top by 3 for every foot that's in a yard, and I have 9 feet over 6 feet. Simplifying the ratio, I end up with 3 over 2 feet. So on your test that we have, we'll be looking at a ratio set that needs to be in the same measurement, and then simplify the fraction. Alright, next question. That was basically just our little definitions that we have there. We're going to use that in ratios of sides to apply things in geometric concepts. It says the perimeter of rectangle ABCD is 60 centimeters. The ratio of AB to BC is 3 to 2. Find the length and width of the rectangle. So we know that the distance around, which is perimeter, is equal to 60. So we have P is equal to 60. We have our perimeter equals 60. And then with the ratio of side AB is 3 to 2. So I have whatever the side is, it's in a ratio of 3 to 2. So I don't know what the base number is that I'm taking my ratio from, but I do know that whatever that number is, it's 3 times that. So I can have 3x, and whatever the number is for BC, it's 2 times that. So I have some base measurement that I'm going to use to multiply my ratios from. I'm just not sure which one what that is. So I have 3x as my side length for AB. I have 2x for my side length of CB, and I need to figure out the perimeter of the figure. The one thing I know is that rectangles do have sides that are congruent. So AB is congruent to DC, and AD is congruent to BC. So therefore, if I was going to write an equation that would show what perimeter equals, it would really equal 2 times the length plus 2 times the width. And then therefore, having set the statement 60 is equal to 2 times the length, which was 3x, plus 2 times the width, which was 2x. So I have 60 is equal to 2 quantity 3x plus 2 quantity 2x. Simplifying that algebraically, I end up with 60 is equal to 6x plus 4x, 60 is equal to 10x, and then solving x is equal to 6. So to find the length and the width of the rectangle, I'll just simply take my 6 and plug it back in for my sides. I have 3x here, 2x there, so I have 18, and I have 12. So again, using ratios to find sides of figures. Next question. Next question says the perimeter of the isosceles triangle shown is 56 inches. So a similar type problem. I know my perimeter is equal to 56. The ratio of LM to MN, so LM to MN, which is the base, is 5 to 4. Find the length of the sides and the base of the triangle. Seeing as how we have an isosceles triangle, LM and LN are congruent to each other, I know that this side must be 5x and this side must be 4x. I know then that Ln, by definition of congruent segments, has to be 5x. So my perimeter statement is really just going to be 5x plus 5x plus 4x equals 56. Or in segment terms, Ln plus Nm plus Lm will equal our perimeter. So 56 is equal to 5x plus 4x plus 5x. Simplifying down, 56 is equal to 14x. Divide 14 on both sides, x is equal to 4. If x is equal to 4 and we had 5x, 5x, and 4x, we know our sides then are going to be 20 on both left and right, and also 16. So again, applying the ratio in the sides of a perimeter of a figure. Okay. Next question. Finding the measures of angles. The measure of the angles in the triangle JKL are in an extended ratio of 1 to 2 to 3. Find the measures of the angles. So in that order, we know that whatever J is, whatever K is, whatever L is, it's in a 1 to 2 to 3 ratio. So whatever J is, we'll call it X. We don't know what it is. We know that that ratio is going to be the base unit. It's going to be 1. We know that angle L has to be 2 times whatever that base unit is. So that'll be 2x. And we know that K has to be 3 times that base unit, which is 3x. Well, recalling some information about triangles and their angles, we know that triangle sum theorem states that three angles of a triangle must equal 180 degrees. So therefore, the measure of angle J plus the measure of angle K plus the measure of angle L equals 180. And if we define those as x, 2x, and 3x, then we know that those are equal to 180. We know x is equal, 6x is equal to 180, and then x is equal to 30. And again, if we have a ratio x, 2x, and 3x, and we have 30, we have 30, 60, and 90 as our 3 angles. And it looks like I just mixed up my order here. 2x should have been on top and 3x should have been on the bottom here. Irrelevant in the final result, but the picture we have there. Okay? Let's try another one. The measures of the angles in a triangle are in the extended ratio of 3 to 4 to 8. Find the measures of the angles. So one angle is 3x, one angle is 4x, and one angle is 8x. And we know that all of the sum of the triangles angles equals 180 degrees, and we'll simplify and solve. So we have 15x equal to 180, x is equal to 12, and then we have 3 times 12 is 36, 4 times 12 is 48, and 8 times 12 is 96 for the set of angles. Alright, very good. Alright, finding sides of a triangle using ratios. Triangle DEF sides are in a 2 to 1 ratio to triangle ABC sides. Find all remaining sides. So we know that for every side here in the left triangle DEF, this is in a 2 to 1 ratio. So for every one that's over on the right, for instance side AC, which has 3, there is 2 over on the left. So therefore FD is just going to simply be 6. 2 times what we have on the left will be 3 times 2 is 6. Reversing that statement, if I'm looking at ED, I have 8, and for every 2 that's over here, there's only 1 on the left. So if I take 8 and divide it by 2, I know that I have 4 as my segment for AB. Lastly, moving on from that, I know that if I need to find all of the sides, and I know that I have right triangles here, which should not be given, but we know that they're right triangles. I can use Pythagorean theorem to solve for EF and BC. So I have 4 and 6 listed for AB and DF, and then we'll do the Pythagorean theorem. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. So I have 3 squared plus 4 squared, that's AC and AB. That equals BC squared. 25 then equals BC squared. Square root both sides, and BC is equal to 5. And still using the 2-to-1 ratio, for every 1 that's over in triangle ABC, 2 is over on DEF, so therefore we have a side 10 on the left for EF. So final answer for all of our sides, AB is 4, DF 6, BC 5, and EF 10. Alright, next question. Same type of idea, finding sides of a triangle. Triangle QRS sides are in a 3-to-2 ratio to triangle VTU sides. Find all remaining sides. So we have QRS, it's 3-to-2. So we take a look here. We have UV in the same spot as QS. So therefore we know that we are going to have a 2-to-3 ratio. If we give these variables, things that we're trying to solve for here, we have X, we have Y, we have Z, and we have W. So we can make little proportion fractions here to set up. We do know that W over 2 is going to be equal to 3 over 2. So that we know that if UV is 2, we could do our proportions, or notice the fact that we have a ratio as the base number, so therefore W has to be 3 as well. And we probably have a couple listed there. We have QS listed as 3 and TU as 12. We do also know that if RS is equal to 18, we know that 18 is here. It's in the same spot as TU. Let's call that X again. We have 18 over X is equal to 3 over 2. 6 times 3 is 18. 6 times 2 then will give us 12. So if we mark on our picture here, we have solved for sides TU, which is 12, QS, which is 3, and we're looking for TV and QR. And TV and QR will be solved for using the the Pythagorean theorem. Again, a squared plus b squared equaling c squared. And then we have both of those. We have the 2 squared plus 12 squared equaling VT squared, and we have the 3 squared plus 18 squared equaling QR squared. Solving both of those, we have 148 is equal to VT squared, square root both sides, square root of 148, then simplifies down to 2 square root of 37. On the right, we have 333 equaling the QR squared, square rooting both sides with the square root of 333, and when we simplify that down, we have the 3 times the square root of 37. So we have all of our parts now listed. We have QR, we have VT, we have QS, and we have TU. So again, sometimes it may be simpler just to use the Pythagorean theorem to solve for the missing side lengths. Alright, next question. Solving proportions. So we kind of did this a little bit, or I alluded to it in the last slide, but proportions is a set of 2 ratios that are equal to each other. So we have the ratio AB equal to the ratio CD, and we do know that the cross products are equal to each other. Cross products, we have A times D and B times C. So this statement implies this statement that AD is equal to BC. And we use this a lot then in solving proportions using algebraic expressions. We'll get rid of this little thing right there. So if we have the proportion 4 over x is equal to 5 over 7, we can cross multiply and solve for the variable x. Cross multiply here and here. I'll have 5x equals 28, as I have the implies here, And then when I divide by 5 on both sides, we have x is equal to 28/5. Let's do another one. 3 over y plus 2 is equal to 2 over y. So again, this is another review of algebra. This time we have a algebraic expression with a y plus 2 involved. The same rules apply for solving proportions. We're going to cross multiply top times bottom and bottom times top. Here we will have 3y is equal to 2 times the quantity of y plus 2. And this is where a lot of times people can make mistakes. When you have 2 times the entire piece, y times 2, or y plus 2, you have to distribute. So then we have 3y is equal to 2y plus 4. And when we subtract 2y on both sides, we end up with just y is equal to 4. So we have algebraic expressions there along with our proportions. Alright, let's try 2 more. Solve the proportions. 8 over b is equal to 14/5. Cross multiply and solve. 8 times 5 is 40. 14b then is equal to 40. Divide by 14 on both sides and simplify. b is equal to 20/7. On the bottom, we have cross multiplying happening here. And we have 2 variables now in the proportion. So we will have 6 times x, which is 6x. Times, or is equal to 2 times 3 minus x. We distribute on the left, gives us 6 minus 2x is equal to 6x. Add 2x on both sides, 6 is equal to 8x. And then divide by 8 on both sides, and we have x is equal to 3/4. Again, a complete review from algebra here. Alright, another one, cross products, just making sure that we have this down. We cross multiply. We have 6 times 4x minus 5 is equal to 3 times negative 26. We have 4x minus 30 is equal to negative 78. Add 30 to both sides. We have 24x is equal to 48, negative 48. Divide by 24, and we have x is equal to a negative 2. Alright. Last 2 statements then. Putting proportions together to solve statements or make predictions. This one is about pets. Monique, randomly surveyed 30 students from her class and found that 18 had a dog or cat for a pet. If there are 870 students in Monique's school, predict the total number of students with a dog or a cat. So we have to put a proportion together and then use the solution, or solving algebraically, to figure out what the estimate is. So we know we have a ratio that can be formed. 18 students who have a pet, and a total number of her class is 30. We don't know how many students in the whole school have a pet, that's the x there, but we do know there's 870 students overall. So we have the 18 to 30 is equal to x over 870, and we want to use this to accurately predict how many pets there are, so we cross multiply. 18 times 870 is equal to 30x. Multiply and then divide. And we're estimating that there are 522 students in the school based off of the cats and dog owners in her class for the entire school. So again, defining the ratios, setting up the proportion, and solving using algebraic expressions. Alright, last one. Same type of question. Brittany randomly surveyed 50 students and found that 20 had a part-time job. If there are 810 students in Brittany's school, predict the total number of students with a part-time job. So she went around and asked 50 students, so that's our total population. There was 20 of them that had a part-time job, so we had 20 over 50 as our ratio. We don't know the number of students that have a job in the entire school, but we do know that there is 810 students in the entire school. So here we can cross multiply and solve to see if we can accurately predict how many students have a part-time job. So we'll have 20 times 810 is equal to 50x. We will then go ahead and multiply 20 by 810. We'll end up with 16,200. Set that equal to 50x. Divide both sides by 50. And we have x is equal to 324. So based off of this proportion, we can guess that there are 324 students in her school that have a part-time job. Alright, this ends lecture for today. Problems that we're going to look at in class tomorrow are from page 460, numbers 1 through 19, and 21 through 37. Thanks for watching.